Good afternoon. My name is David Eastwood with Geotech Engineering and Testing. I hope everybody can hear me. Today, what we're going to be talking about is foundation repair techniques for lightly loaded foundations in Texas. And let's see. This is for lightly loaded foundations, like buildings, residential and commercial, less than 5 stories tall, usually. That's what they're used for. Audience, we got about 260 people RSVP'd. Lots of engineers. I can say that some attorneys and some civil engineers and structural engineers. People from different cities. If you need to reach me, my name is David Eastwood. Email is de@geotecheng.com. My phone number is 713-699-4000. This presentation is going to be on YouTube. So if you go to YouTube channel, Geotech Engineering and Testing YouTube channel, you can watch this and send us an email, then we'll send you a CEU for it. There are other presentations out there. There's like 25 presentations on YouTube. So you can watch them and send us an email. We'll send you a CEU. I work with Geotech Engineering and Testing. We're located in Houston. We've been around for 35 years. We do geotechnical, environmental materials, and geoforensics. We got a staff of 60 people, engineers, geologists, technicians. We work all over Texas, Louisiana, Oklahoma, and New Mexico. We have our own rigs, so we can mobilize on projects quickly. If you have questions during the presentations, just type them in the QA section of the presentation. I'll answer it as I go through. We're going to be talking about foundation repair. It could be a school project, City of Houston command station. That's on Wilcrest in Houston. Could be a residential projects in Tanglewood. Be a house somewhere. This is Rice University. You got a lot of CMU blocks there. They're cracking. You see that? More cracks in the CMU blocks. Brick cracking. This is an apartment complex in Stafford. You got tension at the top, heaving at the center. This is another brick cracking structure. It's a commercial project, cracking here. Separations. Galveston Strand was out there, so I took some pictures of the cracked brick there. More brick cracking. More brick cracking. Grade beam cracking. Sam's Club, floor slab cracking. The bedroom cracks above the door, the sheetrock. Floor covering, ceiling covering cracking. This is a Stafford Medical Facility. You can see the cracks in the ceiling covering, ceiling tiles. Sheetrock cracking in a church. This is in Bel Air. More cracks in the sheetrock in the church in Bel Air. Separation in the tile. Tile cracking. This is a exclusive furniture project out there in Richmond. Ceiling tile separations and movement. That's a medical facility in Stafford. That's the City of Houston, the police command station on Wilcrest. See the wall is bulged up because floor slab heaved up. Didn't have any place to go, so it bulged up. See the floor slabs coming up. This, and then see the wall bulging up. This is a bathroom in the school. Tiles are all cracking because of movement. Doors are not closing, they're not square. There's a movement. Doors are not square. This medical facility out here moved, the glass broke. Didn't use the door anymore, they just go through the window. Hovering walls. This is a project on Dairy Ashford. It's a Montessori school. And you can see all the movement. You can't close the door. So you can put your hand in the brick crack here. You see more movements and separations, shrinkage cracks, water standing, cracks at the corner of the brick, drainage, sheetrock cracks, more sheetrock cracks, floor slab cracks, doors not square, moisture coming through the slab. That's a problem, you know, in some slabs, they don't have vapor barrier, or the vapor barrier is already deteriorated or it's too thin. The moisture is coming through the slab. This is a warehouse that, this part of the warehouse, they had vapor barrier. This part of the warehouse, they didn't have a vapor barrier. So moisture was coming through, they didn't know what to do. Here's again, presence of perch water table underneath the slab. Moisture coming through the slab. They got floor slab covering coming up. This is a kind of a drawing that shows foundation repair contractor Yellow Pages advertisement. Back in the old days, San Antonio had the most foundation repair places, followed by Austin, then Dallas, and then Houston, Denver. So we can see where the most of the foundation repair contractors are located. This is when they do inspections on houses, residential. Seems like the first 4 years is you get a lot of inspection, and then 20 years, you get a lot of inspections. So what we're going to be talking about today is we're going to be talking about drainage, underpinning, drill footing, press piling, helical piles, pipe piles, micropiles, spread footings, foundation lifting, polyurethane, foam, mud jacking, lifting, chemical stabilization, chemical injection, line pressure injection, vertical moisture barriers, foundation watering, and combination. A lot of times the repairs are a combination of a lot of these things. So it's just not one thing. This is a typical foundation repair technique back in the old days, and they used to use like a little pad out there, a concrete pad, and lift this stuff up. To start putting concrete piers, steel piers, helical piles, press piling, drainage. When you have good drainage away from structures, this is bad drainage, this is good drainage. When you have bad drainage, you got movement. This is not good, this is good. It's not good, it's not good, not good, not good. Positive drainage from structures, positive drainage. It's not good the water be standing next to this house. The soils are expansive. This part of the house is going to heave up. If the soils are sandy, this part of the house is going to settle because it's going to saturate the sand, makes them so soft that the house may settle. It's a bad drainage here, not acceptable. Not acceptable. Not acceptable. Not acceptable. Look at this office building here. You got drainage going towards the building. Not to mention the big old oak tree over here. Again, negative drainage, Oak trees. Oak trees, poor drainage. That's in Gessner. If you drive around Gessner, you see a lot of these. Negative drainage. Negative drainage towards the apartment complex, causing foundation movement. Negative drainage towards these houses on this street, causing foundation movements. This is West Road, by the way. This is the medical facility out here in Stafford. They backfilled the area with gravel, flat drainage. Water would stand over here. The gravel permeable, water can get in there. Again, you can see that. Gravel. You want to have positive drainage away from the building and trees as far as possible from the building. It's a positive drainage. Positive drainage. Positive drainage. It's good drainage there. Positive drainage. On the houses, they put some drainage ditches between the two houses. See the drainage ditch here. When you got a house out there, you want to put some kind of a space between the house and the driveway, so the moisture around the whole house is uniform. You don't want to have a situation like this where the paving is against the grade beam. You got a horizontal moisture barrier here. So this part of the house in the front is going to heave up. This in the back here, it doesn't move as much. So you're going to develop cracking. Sprinkler systems. If you put sprinkler systems in the areas around the structure, you want to put them all around uniformly. The sprinkler system should be all around. This is a little skirt here in Fort Wayne County. Helps the building don't move as much. Sprinkler systems. They got bed liners with gravel, really a bad design. Got expansive soil water just sits here and cause heaving of the structure. It's a capital one over here. You got over here, you got planter areas. Over here, it's got nothing. So this side moves up and down. This side does not move, so building cracks. Yeah, we got good old Gary Boyd here. But with flower beds next to foundation or water may cause problems. Yeah, obviously, if you have planter areas and you water here and you don't water here, you're going to get differential movements. And if you have it around the whole building, as long as you've got uniform moisture and keep it up, then you don't have any problems. Movement occurs when you go from a dry condition to a wet condition, go from a wet condition to a dry condition. So if you're totally dry and you get wet, you're going to have movements. If you're totally wet and you get dry, you're going to have movement. So as long as you keep it moist, or totally dry and never get wet, you're not going to have movements. But that usually doesn't happen. You got a case here where you got planters here and nothing here. So this is the Capital One Westheimer. It's got a lot of movements. These bed liners are not good. They hold water, gravel. They all hold water against the foundation, and cause movement. This is another deal. These guys got bed liner with gravel and sprinkler system in there. That's a bad design over there. That's in Friendswood, highly expansive soil. Things move quite a bit. This is another building out there in Pearland. And you can see they got gravel in here, pea gravel. Below that, you got highly expansive soils with negative drainage and rock bed liners. Again, hold the water against the foundation, causing movement. Negative movement, negative drainage here. Planter areas are built up and water is going towards the foundation. This guy's got a fish pond next to his house in Friendswood. It's not good. Some of these AC units, they go through condensation and water comes out from the pipe. And if it drains out there in the planter areas, and it can cause heat. This is a house in Tanglewood. This side of the house lifted up because of all the condensation from the AC units. Gutters. Make sure you got splash box on the gutters or extension, or you take it underground. This is not acceptable. You lose bearing capacity, water gets underneath the foundation, and it can cause heave. Okay. There's not going to be a handout, but this presentation is on YouTube. So you can go out there and watch it anytime you want. So if you go to a YouTube channel, you can watch this presentation. This is not acceptable. It's an HISD building. And you can see the depression here. It rains, water comes over here, it sits here in highly expansive soils, moves, the whole building moves because of lack of maintenance. Another building for a school building, you can see water coming in, low area. And water just sits in here, poor maintenance, causing movement. This is another school project in Pearland. And you can see there's no connection here. Water gets over the place, the building's moving. Overloaded guttering system. Water comes down this side of the house all the time. This side of the house moves a lot because of the lot of moisture. We want to take that water underground to some kind of a storm sewer. So again, the gutters are coming over here on this tilt wall building. Go to an underground drainage system. It's going to an underground drainage system. This is Alan Sattler building in Conroe. You can see the gutter coming in, dumping in here over the pavers, which is okay. Ideally, you don't want to do that, but you know, it's impermeable. It is permeable, water gets in there, it's not good. Again, you can see the gutter coming here. This is better. You got a tall, longest splash box I've ever seen on this Alan Sattler building. You can see the water coming away from the building. This is not very good because the gutter comes over here and wet this area here. This area moves up and down. This area here has got paving, doesn't move, so you develop differential cracking. Here's another deal, tilt wall building. The gutters come here and drain here, right here on the paving, which is fine. There's no problem there. These guys are going to underground drainage system. All right, there's somebody else question. When you have a garage with driveway, moisture will be different on the driveway side. Any way to reduce the differential movement other than paving around the entire perimeter of a garage? I mean, you gotta have to either pave around the whole garage or do what's called chemical injection. If you do chemical injection, you will reduce some of the movements. I had a slider that showed about the garage and all that stuff, driveways. Gutter again, the rain coming from the roof, going to an underground drainage system. Again, the gutter, underground drainage system comes out at the curb line. Here's again, the gutters are coming in, taking it away at least 5 to 10 feet from the foundation. This is an Olive Garden out there in Conroe. The water comes here, hits here, come over here, goes to an underground drainage system. This whole area is pretty bad. It's filled with gravel. And if you got the soils that are expansive, this thing can heave up and down. This is a building out there near the Houston airport system, Bush Airport. Tilt wall building. The roof was sloped and the gutters were on one side, only one side. So when it rains, this side of the building heaved up significantly because of the high moisture. So the building had cracked. There was major lawsuits and everything. This is a house in 1488, south of Conroe. Good drainage, but it had a lot of perch water table problems. There are lots of sandy soils. It rained. The area got filled with water. Water got underneath the foundation. If you go inside that house, some areas smelled pretty bad because the water was underneath it, because of the presence of freshwater sand there underneath the slab. Here's when you don't have gutters. You're going to develop these depressions next to the foundation where water sits. This is pecan grove plantation out there in Fort Bend County. A lot of foundation problems over there. Some guy dug this over here. Water sits here and caused heave. Here's the guy trying to stay cool. And he dug out next to the foundation, causing foundation problems. Here's another one the dog dug out. That's pecan grove plantation. If you don't have space for grass growing or drainage, your gutters have to come in and go to an underground drainage system or area drains. These gravel gets saturated and you won't see the water, but it feeds the expansive soils. So when you have something like this, the gutters go into an underground drainage system or put in area drains, get that water away. Area drains. If you have flat areas, you can't drain the water, put area drains in. This is the Olive Garden Conroe. Bed liners, gravel, water sits in there when it rains, causing foundation movement. These walls are, rock with mortar, very rigid. Any kind of movement will cause cracking. So I had lunch one day. I went out there and took a bunch of pictures. The manager says, "Hey, why are you taking pictures of my restaurant?" I said, "I want to take the initial pictures so when he moves, we have some good pictures of it not moving yet." And you can see the planter areas with lots of rock, bed liner. It's not a very good design if you have expansive soils. And if you have sandy soils, because again, all this is just a tub of water. It causes saturation of the sand and can cause building settlement. Check the soils in the planter area. Do not use topsoil. All these planter areas, they build them up with topsoil. Underneath them, they got highly expansive soils. So you take that topsoil, which consists of silty sand next to the foundation, that holds water and cause saturation of the water underneath the foundation, which corresponds to future heave or settlement. Grading, drainage. When you build your structures, you want to have positive drainage everywhere. Positive drainage. Positive drainage, you backfill with clay, not sand. Backfill with clay. You got a low area, you backfill with, fill, structural fill. Don't put sand in there because water gets in the sand, just sits here and feeds the expansive soils and causes the building to heave. Backfill with clay and grade with clay. Sandy clay, grade with it, not sand. You can put a, inch or two of sand on top of it for grass, but not for, grading purposes. Don't use pea gravel. The backfill next to the foundation is permeable and can get to the expansive soils and cause heave. This is a house in Bel Air. The back of the house was heaving up. They didn't know why. They moved the patio. There was a bunch of sand there on top of highly expansive clay soils, causing the back of the house to heave. Engineering analysis. If you look at the soils around Texas, this is where the expansive soils are. Soils in Texas are variable, so you can have expansive soils everywhere. These are the soils that can, expansive soils that can expand up to 1,500%. This is for U.S. Corps of Engineers. Expansive soils in Texas and Louisiana. expansive soils in Texas, expansive soils in Houston, Dallas, Fort Worth, Arlington, Austin, San Antonio, Lubbock and El Paso, Midland. Oh, they're doing good. They don't have expansive soils. If you go around Houston, we start about where I live, more Roman Forest area. You got the clayey sand and silty sands over sandy clays. You go to Kingwood, parts of Kingwood is all pure sand as you get to the Lake Houston. And in some areas are gumbo clays with big trees, lots of movement. Tascasita, you got perch water table, sand over clay, lots of movement with trees. Channelview, Crosby, Dayton, Baytown, LaPorte, Pasadena, South Houston, Pearland, Seabrook, Missouri City, Sugarland, Rosenberg area, all have highly expansive soils, a lot of movement. Combined with trees, cause a lot of foundation movement. Start going to Cinco Ranch, you're going to have sandy soils. And these sandy soils develop perch water table. They're not expansive, usually PBR are less than 1. Ridgeland, Fairfield, sandy soils, Tomball, you got some areas real sandy, some areas clayey. The woodlands, you got mostly sandy soils. You go inner city, Westview, Bel Air, Tanglewood, you got highly expansive soils, a lot of trees and a bunch of attorneys. Question. What's the correct way to place vegetation and landscaping around the building? That's part of another presentation I have. And if you go to YouTube and on forensic engineering of the buildings, there's a whole presentation on effect of trees and vegetation on foundations. So go to YouTube channel, Geotech Engineering and Testing, and look at my forensic presentation. Potential vertical rise is a potential vertical rise expressed in inches. It's ability of the soil to heave up at each part of Houston or Texas. Typical PVR amount of lifting will be equal to the PVR. So if you want to lift the foundation, you're going to at least lift it to the PVR. Typically, we recommend twice the PVR. So if your PVR is 4 inches, we tell the contractor to lift your foundation 8 inches. This is a map I developed for Houston. This is the PVR map of Houston. And you can see out here, you go to Greatwood, you can have as much as 6 inches of movement. Rosenberg, 5 inches. Full share, 2 to 4 inches. Cinco Ranch, 1.5 inch. Brookshire, 1.5 inches. You go to Spring, 1.5. Tomball, 1 to 4 inches. Kingwood, 3 to 4 inches. Some areas 0 in Kingwood because it's all sand. 5 to 6 inches in Crosby. Baytown, 5 inches. You go inner cities, Westview, Bel Air, you're going to have 4 or 5 inches of movement. Tanglewood. Again, measuring the movement, you can see the voids underneath the foundations due to heave. More voids in here. And due to lift, you create voids underneath the slabs by lifting it. These are the voids. Drill piers. This is one of the old faithful type foundation repair techniques. You drill a hole, you find out the exact depth that you need to go to. You make a bell, and then you put some concrete cylinders here. This is the exterior grade beam. You jack against it and lift it. Here's another one. You got steel in it. It's a good system. The problem is the depth. You know, sometimes if you're located in Westview or Bel Air, if you want to put drill piers, you got to go down 18 feet. So it may be difficult to go 18 feet with these piers. Drill piers are the cast-in-place foundation support system. The system can be drilled straight shaft or drill shaft with an underream at the base, commonly referred to as a bell. The hole is excavated in the soil. Steel reinforcement is placed in the shaft. Ready mixed concrete is placed in the hole and vibrated. The main supportive system comes from bottom of the pier with some additional support through skin friction. on the size of the shaft. The concept is to achieve support below the movement active zone to minimize the future movement. You jackhammer the slab. These are hand tools. You put drill with the piers. You can do it with like a bobcat too. That's the bell. You put the steel cage in, pour concrete, put the steel in it, cover it up. Here's you doing and drilling the hole out there again. It's another one. You got a beaver, drill with an auger, drill your hole. Here's again for commercial, uses. You got to use big rigs to drill, to underpin with. You can see this device over here. Use a low overhead type equipment. You go out and drill in the basement. You can see it covered with concrete. These are the columns coming out of the ground. Again, you can see it over here. You go and then drill here with the low overhead machine. These are the holes. You put a bell with a reamer. This is a church building here. Again, you're drilling with a hand here. You got hand tools. Put your pier in. Not good, man. It doesn't take, the gumbo clay here. You put the steel cage in, pour concrete, put the steel in. You go out there and jack up against the foundation to level it or lift it. You see the concrete blocks in here. You shim it. You pour concrete. Interior. This is you go jackhammer the floor slabs. And you drill for your piers underneath the grade beams. Again, you cannot go very deep with these piers. And that's a problem. You can see here, you jack in against the block in here. You cover it up with concrete. The way you determine the pier depth is very important. That's why it makes it sometimes difficult to build foundation repairs or even new construction with piers. The way you put the piers in the ground, here's the pier depth. You got a movement active zone. That's the area that moves. Moisture active zone, which is equal to or deeper than a movement active zone. Then you got the anchor zone. This is a zero movement line. The soils above here heave up. The soils below here do not heave up. When you put a pier in the ground, you got to put it below the zero movement line or movement active zone to anchor it against uplift. On most of these projects in the Houston area and in Texas, we worry more about the uplift than downward movement. So if my active zone is 10 feet in Houston, my pier depth should be about 18 to 20 feet deep. It's kind of give you a rule of thumb there. If you're in Dallas, if your active zone is 15 feet, your pier's got to be 25, 30 foot deep. So that's just kind of give you an idea what the pier depth should be. All right, we got a bunch of questions here. What determines the depth of active zone? Oh, there's a whole bunch of stuff you got to do to figure that out. It's 2 feet below the lowest root fiber. When your soil suction doesn't change for more than 0.027 pf. When the liquidity index becomes vertical, the depth of the sand layer or where you hit the rock. Warren French, what is the opinion of tunneling under the stab, particularly if the backfill is not moisture resistant like clay or not properly compacted? Can it be done properly? I want to get to that warning in a minute. Just give me time. I'll get to the tunneling. The way you determine the active zone depth is when you hit a sand layer. When you hit a hot rock layer, the 2 feet below the lowest root fiber, when the change in soil suction is less than 0.027, when the liquidity index becomes vertical, depth of slick inside, that gives you the active zone depth. But that doesn't mean that's not mean that's a movement active zone. That's just the active zone. Movement active zone is 10 foot in Houston, in Dallas, on San Antonio and Austin is 15 feet. When you know the historical water table, that's how you determine your active zone depth. Here we go, another question. Do you recommend to have a gutter system for residential home? Yes, I recommend to have gutters. So if you got a big tree, your active zone depth is deeper. There's more heave here. When you don't have a tree or a moisture active zone depth, it's shallower. When you put a pier in the ground, you have to worry about two components, the downward movement and upward movement. To resist the downward movement, the compression, you got end bearing and skin friction below the zero movement line. Above it, there's no skin friction. The thing you need to worry about is the uplift. The soils above the zero movement line will grab the pier and start lifting it up. The soils below the zero movement line, they keep it down. You cannot use bell to resist uplift. By the time the bell becomes engaged in the uplift, you're going to have 2 inches of movement where your superstructure is going to be cracked. So when you calculate the pier depths, you do not count on the bell to resist uplift. Make sure you know that. Positive attributes on the piers, they're inexpensive, they transfer a lot of load, and they can carry a lot of load. There's a good load transfer. It's not like, you know, some of the other type of foundations where they cannot resist uplift. Drill piers can resist uplift provided they are deep enough. Negative attributes cannot easily be done in slabs. Groundwater is maybe a problem. Sands may be a problem. Interior piers may have depth limitations. Yeah, if you got, you know, out there in Tanglewood, you want to put piers at 12 feet, you're wasting your money. So those piers got to be at least 20 feet deep. Cut the top of the existing piers, if any, and free them from the slab before lifting. You cannot have existing, you know, construction piers that be there. You got to have to cut the top to allow the repair piers lift the slab and level it. Here's some comments. Some of these piers can fail if you got shallow depth. The pier is going to heave up. Soil conditions may not be conducive to drill pier construction. Like if you have sandy soils, you're going to have caving problems. You got to use what's called slurry method of construction, which is expensive. Improper design may cause pier to move. Too much load on the pier can settle. Soils packs or shears at the bottom of the pier. The cap or the head of the pier is not thick enough and cannot allow the head to crack. The cap or head of the pier is not thick enough. It can allow the head to crack. If you got too much load and you got that, the head of the pier is not strong enough, it will crack. Improper reinforcing steel placement may allow the pier to crack. Improperly shimmed, there will be a space between the top of the pier and the grade beam, and they're not connected. Seasonal moisture content changes on shallow piers may allow it to settle or heave. Shallow installed too steep an angle can allow the pier to lay over, become overstressed when the weight is applied. Yeah, you cannot put it in an angle. Failure to vibrate low slump concrete may allow the concrete to honeycomb. Collapsing of the soils like sands within the bell sloughing shaft can result in accumulation of the loose fallen materials at the base of the pier, which can lead to settlement of the pier when these loose materials are compacted under the bearing pressure. Any gaps that occur around the shaft of the pier from drying can later serve as free path for water to come down. Again, if your piers are too shallow and you got expansive soils and the soils around the pier to basically shrink away from the pier, water gets in, you're going to get heave. Sometimes the pier is installed properly, but the blocks, pads, cylinders on the beam bottom may shatter along the beam to resettle. Okay, so you got to put, strong stuff out there. The concrete above the piers got to be at least 5,000 PSI. Press piling, used a lot. You got a block at the top here and here. These are, 8" by 8" by 12" block here, or 6" by 6" by 12. 8" if you got a lot of load. You got a cable going in the middle of it. These are the blocks. They usually are 6" by 12 inches, 6 inches in diameter, 12 inches high, penetrating to the ground. Again, here's another one. This is the corner. Here's the interior. And you got a cable going in the middle of it, or steel. You got a steel bar in the middle, maybe. It's a typical press piling system. You jack it against the foundation and use the load of the house or the building to resist, to make it go down deeper. That's your load. You jack it against the existing foundation. Sometimes if you want to get it deep enough, you may have to use a steel piling at the bottom of the press piling. You start with the press piling, you start pushing it in, and then, then you put press piling on top of it. Typically, you want to be able to use, these piers go down to about 16 feet. Typically, they go about 20, 25 foot deep. There's a cable that comes over here and is basically locked up over here. It's called shore lock. These are the spacers. Minimum piling depth is 15 feet. They usually go 2 to 25 foot deep. Again, you can see the jack in here. You jack it against the grade beams. These piles may consist of precast segment installed by one on top of the other, pressed into the ground. The weight of the structure is used to basically reactive force to allow the segment pulse to be driven into the soil. There's a hole in the middle of these cylinders so that you can run a cable through it. These are the cylinders. You drill the hole, pilot hole, you start putting your stuff in. This is the cable that goes through the cylinders. Again, trying to put a cable in there and tighten it up. And you jack him in there. You push them in against the foundation system. You push them in one by one. Again, you may have to use a steel piling near the tip to get it down deep enough. But some areas you can't get penetration. So you use a steel piling. It's the jack. This is the block on top of the press piling. And you can see that. This is how it's being repaired. These are the press piling underneath the foundation. You shim it. For concrete. That's how you level it. Tunneling. When you use press piling, you may tunnel underneath the slab to go out there and put the piers in the ground underneath the grade beams. If you don't have grade beams enough, you may have to put a steel beam underneath the slab and jack against the steel beam. Tunnels are usually about 3 to 4 foot in width and height. Here's a tunnel. You dig out the soil. You put your piling in here against the exterior grade beam. Well, interior grade beam or exterior grade beam. Start jacking against it. Again, you may have to add a steel beam here if you don't have good grade beam. You jack up against the steel beam. Backfilling tunnels may be backfilled with unside soils. They cannot be properly compacted. The voids are then backfilled with polyurethane. In some cities, the tunnel is backfilled with a flowable fill. The problem with that is with a flowable fill, the problem with that is, of course, if you want to get back in there, get your plumbing, it's going to be a problem. You can't dig it easy. In most cases, tunnels are not backfilled except at the 3 foot within the exit of the tunnel. They're just not backfilled. Backfill for commercial projects. And here, you try to backfill the area. You go in the tunnel, you bring in structural fill. Select structural fill. You don't want to put gumbo clay there. Here's the piers, press piling. You bring in the soil. Try to compact it the best you can. Usually it's very hard to compact that soil. Residential. Again, you got a beam over here. Jack against the beam. Try to compact that soil. Add water to it if you need to. It's hard to get good compaction. And then after you do that, try the best you can on the compaction. You go in there, use polyurethane material, and you just drill a hole, and you inject the polyurethane in there. That would kind of fill up the voids. When you inject it with this foam material that goes and lifts the slab up, you fill in the voids. You fill up the voids, you don't want to lift up the slab. It's a polyurethane. Sometimes it comes out from a hole next to it. You just have to clean it up. That will fill up all the voids. I guess this is the injection inside the house. So, and then you cover this stuff up. That's you cover basically the tunnel entrance. In areas of shallow water table, perch water table may exist. And then in the tunnels, you may have to put some pumps. If you want to know about press piling, there's the F.PTI Foundation Performance Association document, design, manufacture, and installation guidelines for precast segmented piles for underpinning by a structural committee of the Foundation Performance Association. You go to F.PTI website and there's a lot of good information there. Comments: cut the top of the existing piers, if any, before lifting the slab using piling. We already talked about that. More than 50% of the press piling is installed without any steel, which is not good. Common system is mainly utilized where the driving resistance is such that to allow the weight of the structure to be used to develop the force necessary to obtain sufficient pile penetration. Again, the sufficient pile penetration is about 16 feet. Most of the time they go 20, 25 foot. High pressure water injection technique called jetting or other methods such as pre-drilling may be used to break up and allow for additional penetration. This is categorized as driven displacement pile for press piling. Load transfer occurs to the foundation soils primarily through the skin friction. Interconnection may consist of steel bar, threaded rod, or cable that's inserted into the hole, performed through the center of each concrete segment along their longitudinal axis. As an alternative method, interconnection may be to bond the segment ends using epoxy or other tough adhesive. So you can connect them with that, epoxy. Precast concrete piles are not able to resist significant bending moment due to lateral loads. Interconnection may help avoid detrimental vertical misalignment of the pile while it's being driven. Interconnected segment of pile is not likely to resist uplift loads due to expansive soils. Precast segmental concrete piles will not provide resistance against uplift. The final depth of each pile will vary from pile to pile. If a void exists under the slab, subsequent to the lifting, treatment, the void should be determined on an individual basis. Sometimes you want to leave a void under the slab to allow the expansive soils to heave up into the void. Geotechnical and structural analysis would be value. You got to do geotechnical work when you do underpinning. Minimum compressive strength of the concrete should be 5,000 PSI. Reinforcement should be per ASTM standard. Pile head, same as the properties of the segment, 5,000 PSI. The steel should be corrosion resistance. Epoxy grout, epoxy paint, galvanized. Okay, bare steel shims will rust. The pressure from the rust can move heavy structure above. Within galvanized should be used to avoid lifting. Obviously, a galvanized system would be probably much better, but I don't think these guys are using any galvanized shims. I think they're just using regular steel. But galvanized is definitely better. Okay, is there anything from Craig? The U.S. states that they do not fully backfill the hole to allow future movement of the soil, and it does not cause a structural issue due to loading being on piles. Does this destabilize the adjacent areas not loaded by piers? Most of the times, they don't backfill the tunnels. They just let it sit there and just backfill near the exit. But some places, require backfilling, and I showed you guys the pictures. Try to backfill the best you can, and then you go out there and use polyurethane to fill out the voids. I prefer for them to be backfilled fully. When you do a piling installation, you're gonna have to have a work plan. Make sure you know the utilities, plumbing leak test, groundwater surface control. If there are existing piers, we need to cut the top of them, stockpile the segments. For small loads, you would use 6 by 12 inch segments. For heavier, you would use 8 inch or 10 inch by 12 or larger. Keep driving records, hydraulic pressure, pile depth, axle alignment, lubrication, load sharing, refusal, pile depth. If there's water jetting, pre-drilling, how much lift you need, Final elevation survey, restored landscaping. Helical piles. Your grade system. Helical piles foundation system is an in-bearing anchor screwed into the soil by hydraulic driven equipment. Helical piers are steel pipe or solid square stock with helix plates attached to at intervals as the shaft rotates and screws into the soil. Once installed, the bracket is used to transfer the weight of the structure from foundations to the helical piles permanently. So this is the bracket in here. This is the helixes. See the helixes here. Yeah, this is the bracket right there. This is the steel rod that's connected to the helixes. And again, these are the helical piles segments. Drill them next to the foundation. This is the top of them. You put steel in there, full concrete. Again, here's the bracket. Here's the helical piles. The bracket. You screw them into the ground, you lift it. You adjust the foundation height as you go deeper. Start lifting up the foundation. Here's drilling in here, helical pile on a commercial project. Here's the bracket. Again, the bracket is used to lift the structure grade beam. And you can see them like that over here. That's the helical piles for commercial project. These are the rods. Interior installation. You jackhammer square areas. You put your helical piles in. Drill them all the way in. Put steel in it, then pour concrete. Here's a helical pile for underpinning. Drive segments at a time. You like them to be at least 20 foot deep. See the bracket, helical pile. Positive attribute, they got small surface area on the rod. Would not be picked up by expansive soils because it's small. The rod, it's got small, it's 2 inch by 2 inches. So expansive soils cannot lift it. Easy to install inside and outside the structure. It may be more expensive than some of the other methods. Improper spacing may cause overload of the pier helical pile. Pier is not installed in the correct angle may allow the shaft to lay over when the weight is applied. Not installing the pier to the proper torque and depth. When we talk about piers, we talk about helical pile. To the proper pier and torque depth below the active zone may allow the pier to move with seasonal changes. We like it to be at least 20 foot deep. Improper anchorage of the steel brackets that are used to support the grade beams on top. Helical piles can result in connection slippage and settlement of the grade beams. You need a helical pile geotechnical report when you design helical pile systems. Typically, you go out there and do borings. These borings go about 40 foot deep. Hot piles. They're a good system. They're really a good system. I really like pipe piles. Steel piles can be pressed in the ground using the weight of the structure to support as resistance. Steel sections are pressed into the ground, one on top of the other, until neither resistance is met or onto the rock or other load capable strata. The main support with the existing system is the skin friction generated on the side of the pipe sections, unless pressed down into the rock where you have end bearing. This system attempts to gain support for foundation down past the active moisture zone depth of the soil to minimize future movements. Again, on these, we surely like to have them at least, really 20 foot deep. These are the pipe segments. These are steel pile systems. Here's the bracket. You hydraulically push them into the soil. Or you can, of course, you use the weight of the structure as a resistance to push them into the soil. They're usually about 3 inches in diameter, so you can push them into the ground easily. You can see them like this. Again, you push them against the foundation system, against underneath the grade beam. Use the weight of this foundation to resist, to push it down. Okay, here's the deal. You can use hydraulic. You try to use the equipment to push this thing down against the foundation. Again, this is a steel pipe here, cracked brick. Steel pile. These are steel piles in here. The top of it. It's the bracket going against the exterior grade beam or interior beams. This is a house in Conroe. We're using steel pipe here to level the foundation. Is the bracket that goes on top of a steel pile. You jack against, you basically push it against it. Here's the jack. This is how it controls how much load on each jack. You have to have multiple jacks. On a typical house, you may have 30 jacks. Try to lift them all at the same time. Otherwise, you're going to get cracking. Here's a typical placement. You put them in segments. You hydraulically push them into the ground. Positive attributes. Small surface area. Will not be picked up by expansive soils. Easy to install inside and outside the structure. You can do tunneling. And you can put them in. More questions. Please explain how the strength of the piling are calculated. Do not have experience with any buckling failures, especially deeper penetrations. Yeah, I'm not saying that there's no buckling, but most of the time you got all that soil resistance, lateral pressures, so there's no buckling. So the strength of them, load carrying capacity is basically the pressure that you put on it times the area. So some of these piles got 18,000 PSI load on them, push them in. So you can tell what kind of a load carrying capacity they have. Again, you put these things 5-6 feet apart and you have to do them at the same time. You have 30 jacks, all hydraulically controlled. lift the whole thing at the same time so that you don't have differential movements. It may be too expensive. They're not expensive. It's more expensive than other methods by using steel piling, but this is really a great system. If not pushed to refusal, the shallow pipe may move as seasonal moisture changes. If not pushed with the correct angle, the pipe may lay over or bend. The pipe pile can be overloaded, causing shaft to bend. Improper moisture to the pile, such as poor drainage, waterline can cause the pier to move if it's not deep enough. The structural problems are not conducive to steel pipe pile. For example, insufficient steel at the bottom of the beam stop or not enough weight to allow the piling to go to the proper depth. If contractor did not clamp the brackets immediately after driving the piles, the pile will spring back and lose some of the bearing pressure. Drive can cause a skin friction release and allow the depths of the pile to move. Now, these piles got to have a sleeve on them in areas where you got expansive soils. You put a sleeve on top of the pile. In other words, you have a sleeve over the piles so that the sleeve can move up and down, but the pile will not move up and down. The sleeve should be to a depth of 10 foot in Houston, Dallas, San Antonio, and Austin. The sleeve should be 15 foot deep. So that's how you resist uplift due to expansive soils. Micropiles. Micropiles are great, especially Dallas, San Antonio, and Austin, where we have rock. We use them in Houston too, not as much. These are micropiles, jacking against the beam. Here it is the pipe. You drill with it, and you put high strength grout in there. These are hollow bars. This is the bit you drill with. You got your bar in there. You have two types of grout in there. As you drill it and all that, you put the grout in to get all the cuttings out, and then you do another grout to fill the whole area with high strength grout. Here's the steel centralizers. This is the coupling. This is the drill rod. And that's the grout. It's the drill bit. Again, you can see that in here. This is the hollow bar. This is a flushing grout. Inject that through the bar. The flushing grout stabilizes the borehole and flushes the cuttings out. The hollow bar with typical length of 3 meters, 9 feet or so are coupled and drilled to the required depth. After reaching the final depth, pressure injection continues. With the continuous injection station, the flushing grout will be replaced with a richer grout. So this is the richer grout. This is the flushing grout. This is the hollow bar. Final grout with the water cement ratio of 0.45. Here's the flushing grout, soil cement mix. And basically solidifies all the soils around it with the grout. Here's a typical helical pile, not helical piles, micropile. You can see it just solidifies everything around it with the grout that it has. A very good system. Spread footings. If your soil is non-expansive, if you want to level the foundation, you can use the spread footings. Simple column footing, stepped column footing, step wall footing, That's the beam. You put your spread footing in there. You got rebar in it. It's the soil. These are spread footings. Spread footings, you dig them in. Put them in, put a beam underneath the foundation. You shim it. Again, you don't use this where you got expansive soils. You need to lift the structure, you lift it above the spread footing to level it. You shim it. This is the block on top of spread footings. This is the beam. So the soils were expansive in this area where you put the spread footing and heaved up. So the floor slab heaved up over here. Foundation lifting. You know, some foundations due to flooding, you want to lift them up. You core first on the foundation system. And the core drops, that means there's a void there under the slab. This is the crack. The floor slab. When you go underneath it, you see this big void out of here. It's where the crack is. These are vapor barriers deteriorating. This is the grade beam. Soil under the slab has basically settled away from the slab. There's a void in here. Foam injection. Foam injection is usually used to lift the areas of a slab by injecting urethane-based foam material under the slab area. The foam expands, creating pressure to raise the slab after the injections. The lifted area of the slab would sit on top of the foam. So if you have voids under the slab and you've got non-expansive soils, you can use foam to level the slab and lift it up. Polyurethane lifting. You know, Geotech is one of the old guys, but everybody have them nowadays. You inject it and lift the slab. Here's the Geotech. Here are the chemicals. Drill a hole. You put a stem in there. Put the chemicals, it starts injecting it and lifts, it fills in the voids and lifts the slab. And see how you lift the slab. You can lift your sidewalks, flat work. And you can see residential projects, settled driveways. That's before, after. Does not change the soil characteristics. If the soil moves, your foam repaired foundation will move. Comments. If the soil moisture content changes, the slab will move. This shallow repair system affected by active moving soils. Again, if you got expansive soils and the soil moves, your foam foundation repair will move. Moisture changes from broken sewers or water pipes under the slab. And when the moisture changes, the soil heaves, the foam repaired foundation will move. Trees again will affect it. Trees will suck the moisture, cause settlement or heave. Extreme seasonal moisture changes can cause a slab movement. Foam will not prevent it. Failure to control the amount of foam injected can cause bulging of the cracking of the slab. Prior to hardening, excessive water from an overlay. Mixed foam mix can seep into the expansive soils, increase the moisture content and cause heave. Excessive high pressure from the injected foam can cause damage to blowouts. If utility lines, holes or cracks are there, the foam may possibly enter the holes and fully or partially plug the lines. So mud jacking is just like polyurethane, except you use cement and sand. Mud jacking is a procedure whereby foundation is lifted by pressure injecting slurry composed of sand and fly ash or topsoil and cement between the slab and the soil. Here's they're trying to lift the paving. So they got cement, sand, they mix it together. They drill a hole. And then jacking underneath it to lift the paving. It fills the voids. Again, here is you're mixing the grout, sand and cement. Drill your holes. This is a commercial project building in Fort Bend County. You got the voids underneath in the hole. You fill up all the voids with the grout to level the structure. Not used very much in lifting foundation slabs. We use it a lot for paving. Used for pavement leveling. Do not change soil characteristic. If the soil moves, the slab moves. Mud jacking, if the soil moisture content changes, the slab will move. This is a shallow repair system affected by moving soil. Moisture changes from the broken sewer and water pipes can cause the slab to move. Trees can affect it. They can cause settlement or heave. Extreme moisture, seasonal moisture changes. Mud can become entrapped by tree roots. Unknown object cause uneven lift. Failure to control the amount of the mud injected can cause bulging or cracking of the slab. Excessive high pressure from the injected mud can cause damage to or blowouts. If underground utility lines or holes, the grout may possibly fill them up and plug them. Carbon fiber crack repairs. If you got cracks in the wall, one way you can do that, of course, you can put epoxy grouts in your crack. And you also can use what's called fiber reinforced carbon. And you cut a groove about 1 inch deep, put the carbon fiber in, and epoxy glue. That makes the whole thing real strong. You can see the stitches on the crack in the slab. You got carbon fiber with epoxy glue. You can basically grout on top of this, paint it or whatever. But this slab stitching of the cracks is really good with carbon reinforced fiber. Corner pop outs, when the corner of the grade beams break, you can also put them back together with carbon reinforced fiber. It's black, you got to paint it maybe. That's a corner pop out. Lifting, due to flooding, we may have to lift the foundations. And you can see that you got to put multiple jacks, control them at the same time, lift the whole thing at the same time. People die underneath this thing here. You got hydraulics there. You lift the whole thing up at the same time. Then you got to go put in your perimeter wall in there, for example, your interior grade beams, build up with concrete. Here's lifting the whole thing up, jacking against the foundation. These are the grade beams. Interior walls, floor slab. Here we're lifting the whole thing up. This is due to flooding. It's completed. Look at that driveway. I guess it doesn't flood anymore. Soil injections, chemical injection. If your soils are expansive soils, you can do chemical injection used to pre-swell the building sites, pavements, and parking lots. This is a chemical material, it's got sulfuric acid in it, pH of about 6.8. What it does, the ion exchange, clay particles are negative. It reduces the negative charge on the clay platelet so it doesn't absorb water as much. So it makes the soils non-expansive. The depth of injection should be about 10 feet in Houston. Dallas, San Antonio, and Austin should be 15 feet. This is how you inject it. This is sienna plantation. We're injecting to make the soil non-expansive. You can see the tractor coming in. These are the 1-inch diameter pipes, 24-inch spacing. These are the chemicals that are injected all the way down to 10 feet. This is the hole they go in. You can do it by hand or existing foundation that's going to experience some movement. You want to stabilize it, you go out there and you do chemical injections inside and outside the house. There's a mini storage that are moving with chemical injection around it. And here's another structure. Move the tiles, drill the holes, you do chemical injection. Or remove the slab, you do chemical injection and put in a new slab in. So I don't know, somebody's asking, how is the soil improvement measured after the chemical injection? So what we do is, when we do chemical injection, we get sample of the soil, we run swell test. Swell, we usually have a swell less than 1%, actually 0.8%. Yeah, then we approve it. If the swell starts becoming like 1 or 2%, we reject it. So you got to do chemical soil testing before and after injection. Does the chemical injection change the soil characteristics? Yes. It supposedly permanently it changes soils from extremely expansive to non-expansive, and also makes the soils stronger from a stiffness standpoint. Lime slurry pressure injection. You mix the lime in a tank with water. You inject it into the soil. You go down 10 feet in Houston, Dallas, San Antonio, Austin, 15 feet, just like the other kind. They don't use that anymore as much. You use chemical injection now. You don't use lime. Soil types where chemical injections are effective, the soils with a lot of cracks, so that the chemicals can travel into the soil easy. The more cracks you have, the better. Vertical moisture barriers, root barriers. You want to put the trees away from the building as much as you can. If root systems go next to the foundation, you would do vertical moisture barriers, root barriers. They're usually about 4 foot deep, 5 foot deep. You can use bio barriers, root system hit it when they stun them. It doesn't penetrate them. Yeah, depth of seasonal change. Get them as deep as you can. You put the moisture barrier and or root barriers. Root barriers, we like them to be at least 5 feet, and moisture barrier as deep as you can get them. You can get them 7 foot. Put them at 7 foot. Just depends on the equipment. You can get it that deep. Here's a 6 foot moisture barrier. 15 mil. Ideal depth of a vertical moisture barrier is a zero movement line. That's impractical usually, because zero movement line is maybe 10 foot in Houston, 15 foot in Dallas. You can't have equipment that can dig that deep. Residential moisture barrier. Root barriers are designed on top to stop the growth of moisture draw of the roots under in proximity of the foundation. A trench is dug and intended, and the barrier of concrete, polyurethane, biocide, treated mesh, or other material is placed to block the growth. Most barriers are 48 inches or less. Moisture barriers can be either vertical or horizontal. Both types designed to minimize changes in moisture content used in construction. If it's horizontal, you really want it to be at least 9 foot long width. Vertical, as deep as you can get. A vertical moisture barrier is installed by excavating the soil near the foundation, installing a waterproofing barrier. Depth of moisture barrier will be determined by the soil type. A horizontal barrier is waterproof, extends horizontally from the foundation and may be above or below grade. And you can see the moisture barrier here going 5 foot. You fill up with gravel. It rains, the water comes over here, goes to a sump pump system. You got a perforated pipe here going to the sump pump. It's the exterior grade beam. As development moves further north and into the wooded areas, can moisture zone be deeper than 10 feet? Around Houston, where you have a lot of moisture, is 10 foot deep, maximum. You start going to deeper areas, your moisture active zone can be deeper. But the zero movement line is about 10 feet. That means your active zone may be 20 foot deep, but the soils at 20 foot is not going to move. The top 10 foot is going to move. That's the one I worry about, what's going to move. You got slick insides at 25 foot deep. That means your active zone is 25 foot near astrodome. But your movement, zero movement line is only 10 foot deep. So again, your active zone depth must be much deeper than the zero movement line. If there are existing roots growing under the slab, should they be cut? You put a root barrier. Yeah, we typically cut the roots and hoping that it's not going to kill the tree. And all that depends. If the tree was put in there at the same time as the house, when the tree dies, the soil is going to heave up to what it used to be, because root systems suck the moisture and causes the soil to shrink. If the tree was there before the house or the structure was built, when the tree dies, that area is going to heave up. So you have to consider that when you're cutting the roots. Here's a house in Conroe. It's got movements. Putting a vertical moisture barrier in there. You dig a trench in there. You put gravel. Got PVC pipe. Perforate it with fabric. Impermeable. You put it all around the house. Get that water away from the foundation system. So this is, you put the PVC pipe, you put gravel around it, you got fabric, impermeable. Keep that water away from the foundation. You take that to a sump pump. Commercial root barriers. Here's a project in Stafford, Medicare building. A lot of movement. Dug out next to the foundation. You put a fabric down, you put gravel. Start compacting it. This is your perforated pipe. You put it in, take it to a sump pump system. Put fabric there, impermeable fabric. You glue it to the grade beam. This is a sump pump. Compact, bring it up, compact, put a clay on top of it. You cap it with impermeable clay. You compact it. Run density tests. You put steel in it. Pour concrete. What it looks like. If roots found at 15 feet, where you would call that active moisture zone? Yes. If you got a root fibers at 15 feet, your active zone is 17 feet, 2 foot below the lowest root fiber. Okay. Here's good. I don't understand the difference between the active moisture zone and zero movement line. Active zone is that the soils within the soil to a depth can change. So, you know, like again, I use the astrodome, you know, in that area, you know, over there, the active zone depth is about 23 foot deep. But the zero movement line is only 10 foot deep. That means soils within 0 to 10 feet will move, but the soils below 10 foot do not move because of the surcharge loading does not allow it to move. Okay, another question. What vendors did you do the drain system are you describing now? What vendors do the drain system you are describing now? I can't understand the question. Please repeat the question. Horizontal moisture barrier. Again, you can see this thing here, capital 1. You got planted areas all around it on Westheimer. The building was moving around, cracking. You got planters all around this one. But it was causing a lot of movement because of all the moisture and the tiles were coming off the building. A lot of movements in the inside and outside. They had gravel next to the foundation with a bed liner holding the water next to the foundation. Here's the bed liner. So we went out there and covered everything up and put pots there. That way, there's no change in moisture, there's no movement. Another question, is the zero movement line is the same in Dallas, Houston, Austin, and San Antonio? No. Zero movement line is 10 foot in Houston, Dallas, San Antonio, and Austin, 15 foot. What vendors are capable of designing and installing moisture barriers systems? Oh, a company like Ann Nelson can do it, Due West, Olshan, Ramjack. There's several people. If you go to Foundation Performance Association website, it shows you the name of some of these most reputable people. These are the, again, you see the pots there. Another question here. In Lubbock, Texas, rebar in vertical cells and bond beams of the CMU walls basement have rusted. Rebar and spalled face the shell of CMU, reducing the vertical load bearing capacity. Can chemical and stabilization used to stabilize non-expansive soil backfill behind not-through basement? No. Chemical injection that we're talking about here is not effective in that system. You don't have expansive soils, it really doesn't work. You may want to consider using something like a compaction grouting or something. Another question, what is the zero movement line different in different areas? What determines zero movement line? This is the climatic conditions. The less rainfall you have, the deeper your zero movement line. Or well, the deeper, the less rainfall you have, the deeper is your active zone, and your zero movement line will increase if you have low rainfall in expansive soils. Okay, got to be expansive soils. That's why Dallas, San Antonio, and Austin, the rainfall is a lot less than Houston. Therefore, their zero movement line is much deeper. Okay, root barriers. Soil expansion and contraction will occur with seasonal weather changes. The mesh root barriers allow the moisture to penetrate. The impervious barriers will not allow the moisture to penetrate. Caution should be utilized when water leaks between the impervious root barriers and the slab. The source of moisture may be from plumbing lines, sprinkler system, watering system, downspout, poor drainage. The entrapped moisture can allow soil shrink, soil problems, allowing foundation to move. Root barriers may not be deep enough or may have soil above them, therefore allowing the roots to grow below or above it. Property owners should remove wayward roots if they grow past the root barrier. Make sure it doesn't kill the tree. Root barriers that are used chemical to prevent root growth, they're limited 10 years. The bio barriers only last 10 years. Root barriers that consist of thin membranes can be punctured during the installation. We recommend minimum of 15 mil. Root barrier installation may cut the existing trees already extend under the foundation as they wither to die. Surrounding soil gain moisture and it causes heat. Yeah. So you got to look at the trees when they were planted. Thin membranes used for horizontal or vertical moisture barrier may be punctured, torn. F.PTI RC01-0 post foundation repair. Low-rise buildings, it talks about a lot of this stuff. Horizontal moisture barriers such as polyurethane are subject to degradation due to ultraviolet radiation. Member of vertical moisture barrier may be punctured from tree roots. We recommend minimum of 15 mil. Horizontal moisture barriers can sometimes result in increasing the amount of moisture below the barrier, known as hydrogenesis, the cooling of the ground. Yeah, it does that, which can in turn cause heave. Yeah. Horizontal moisture barriers may eventually walk away as a result of shrink soil problems. Insulation of the vertical moisture barrier can cause severing of the existing tree roots. You can cause same problem described with the root barriers. Again, if the trees die, if the tree was planted at the same time as the structure, the soil will heave up to the original condition, so it's not bad. But if the tree was there before the structure was built, it will cause excessive heave when it dies. Vertical moisture barriers is normally designed to keep the water penetrating under the building and also prevent the water from migrating away from underneath the building, which can cause heave if you have a sewer leak. Foundation watering, perimeter foundation watering system, due west does that. Perimeter watering system are used particularly in expansive soils to hydrate the soils around the foundation to avoid drying and shrinkage. Most systems emit a small amount of water on a regular basis to keep the moisture content even through the natural cyclic weather changes. System range from very simple manually operated to highly complex automated systems. Here's a soaker hose system. You put them around the foundation, water comes out. If you got expansive soils and if the foundation system consists of a slab on grade system, it works. If it's sand or you got pier foundation, it doesn't work. Here's a soaker system. You dig a hole, you put it in, it comes out, control box. Here's the one on the top that's not any good. Put a soaker system here on the top. Due west foundation watering system. The due west foundation watering system is professionally designed, installed, and features subsurface drip line. The system is specifically designed to maintain and minimize seasonal moisture changes. The system includes a backflow device, a filtration unit, a regulator, automated valve with timer, controller, and weather sensor. Backflow wind strainer, pressure regulator, weather sensor, controller, control valve, drip tube. Here's the pipe. It's got a hole in it every 12 inches. It emits about 0.9 gallons of water per hour and around the whole structure. Here's like the hoses here. Delivers 0.9 gallons per minute every 12 inches around the drip line. This is the control box. That's how you put them in the ground. You dig a hole 12 inches deep and you put them in. Drip line is installed by 12 to 18 inches away from the structure to 12 inches deep. Drip tube will be placed around any concrete patios, wood decks, AC units, sleeve under the sidewalks. You can see it going like this. Comments: using areas where expansive soils are present. Don't use it in sand. So you cannot use it. Don't use it north of I-10. Use it south of I-10. Do not use where there is sand. Here's a house in here where we have a slab on grade system on expansive soils, not piers. Do not use this system when you have a slab on fill on piers. The cost is typically about $3,500 each. It's probably more than that now. Electric sensors may function and cease to operate. If that happens, you may have problems. The system may allow water to run continuously. You may have problems. Overwatering can cause adverse movement. The soil type may not be conducive to watering system. Don't use it in sand. Watering around the foundation system to attract tree roots and cause foundation that cyclic movement encapsulate during the periods of high and low moisture. Lack of maintenance by homeowner can cause the system ineffective. Automated system, loss of power due to severed wires can cause failure of the system, and dramatic foundation settlement could occur if the system is disabled. Combination stabilization technique. That's what we use for most structures. This is a school project out there in Pearland. 60,000 square foot, one-story structure. Poor drainage around it. You got a lot of oak trees. Planter areas, bed liners. The gutters drain next to the foundation system. Here's the building. Had movement. If you look at the building movement, you can have as much as from minus 0.5 to 7 inches of movement throughout the whole floor slab areas. Minus 3.25, minus plus 1.6, minus 3.5, minus 5. So there was a lot of movement in the slab. A lot of cracks inside and outside, sheetrock, brick. A lot of cracks, trees. Repair techniques. Level 1, drainage, landscaping improvements, leveling. Because we had to level because it was out of level. Level 2, vertical moisture barriers, drainage, landscaping improvements, leveling. Level 2B, chemical injection, landscape improvements, leveling because it was out of level. Level 3, foundation underpinning, drainage, landscaping improvements, and leveling. Level 1, drainage. Remove all the trees around the building. Check the topsoils in the planter areas next to the grade beams. Remove the topsoils and put gumbo clay in there. Remove sands and cohesion topsoils 5 feet away from the exterior beam. Remove bed liners, planter areas all around the building. Remove all the soils around the exterior beam. 6 inches below the brick line. Provide positive drainage away, 5% in the grass, 10 feet away from the building. Level the floor slabs using polyurethane, such as Geotech or mud jacking. Check the roof design, make sure the gutters can handle the rain. Install bricks at 20-foot brick joints at 20-foot spacing. Replace all the cracked bricks. Level 2A, put vertical moisture barriers and drainage, landscaping, and leveling. Conduct level 1 improvement, put moisture barriers to a depth of 6 feet. Level the slabs using polyurethane. Here's the moisture barriers going to a depth of 6 feet. It's a 15 mil impermeable moisture barrier to keep the moisture constant underneath the slab. Moisture barrier goes all around the building. Level 2B, chemical injection, drainage, and landscaping improvements. Conduct level 1 improvement, do chemical injections at 12-inch vertical intervals. Swell test can be run. Maximum percent swell should be less than 1%. That would stabilize the slab as is. If you want to level it, you got to go in there and use polyurethane material to level it. But this will stop it from moving. Again, you got to cut all the trees and all that too. Positive drainage, gutters. Again, you go inside the whole building and do chemical injection. Level 2C, foundation underpinning, drainage, landscaping. Conduct all level 1 improvements. Underpin in the areas determined by the structural engineers. Drill footing or helical piles should be at a depth of 18 feet deep. Top of the existing pier should be cut. It was one piers. So when you look at the building itself, you see the crosshatch area, got to be underpinned. You know, you can put vertical moisture barriers, cut all the trees. That causes heat. Yeah, I got a couple of questions here. Thank you for the great presentation. Okay, thank you very much. What areas do the state is a school building? What area of the state is the school building? Oh, this school building we're talking about is in Pearland. If you got pictures of the projects, underpinning, repairs, cracked up, send them to me. You know, I got a picture library of 100,000 pictures. So I really use them. Pictures show a lot of stuff. So I appreciate it if you send me pictures. This presentation is on YouTube, so you can go watch it anytime you want to. So it's going to be on there tomorrow. Old version of it is on there now. Program evaluation. I want you guys to tell me what you think of the program. I'm going to send a poll in. Let's see. Please respond to the poll. Got a question? Content, technical, and photos are very informative. Thank you. Oh, you're welcome. My name is David Eastwood. If you need to reach me, my email is d@geotecheng.com. My number is 713-699-4000. These are all the seminars that are coming up that we're doing. So make sure you're on our database. Send me your information so that we can put you on the database. So send me all your contact information. How do we get CEUs? That's a question. We'll send you the CEUs by tomorrow sometimes. The PDH hours will go out within by tomorrow sometimes. Questions? I know I answered a lot of questions as I was going through, so you shouldn't have that much more questions. But there are other presentations that cover other areas. You can go to YouTube and watch them, or if you want to watch them live, I try to do some presentation every 2-3 weeks. Thanks, David. I appreciate it. Okay, question regarding moisture under foundation. I don't know what you mean by that. What's your question? When you put a foundation on the ground, the slab, the moisture starts gathering underneath it due to capillary effect, which increases the moisture under the slab, and with time, that slab starts heaving. Oh, moisture coming through the slab, how you repair it? There are chemicals that you can apply on top of the existing slab, try to minimize that problems. These are certain types of materials that you can actually pour on top of the existing slab that would try to minimize some of the moisture coming through.